All right, so we're going to review our last little bit of Unit 1's homework. This was page 406, question 41. We're also going to do 43, 45, and 49. So for question 41, which you see here, you have to, erase that, you're going to see the problem already. We need to write electron configurations for 4 ions. So we've got aluminum, barium, selenium, and iodine. You're going to do this in their most stable ionic compounds. So basically what that means is their most common ion. And so we learned in class to do this by whatever group they're in. So aluminum's in group 13. We've learned that everything in group 13 has a positive 3 charge. Barium's in group 2. Everything there would have a positive 2 charge. Selenium's in the oxygen group, group 16. So that's going to have a negative 2 charge. And then we've learned that iodine is a halogen, and that's going to be a negative 1 charge. So you definitely have to start with that. The next thing you want to do is you need to think, well, what noble gas would this be isoelectronic with? Remember, isoelectronic means it has the exact same number of electrons, and therefore the exact same electron configuration. So for example, here's aluminum, and if we have a 3+ charge, it means we have lost 3 electrons. Well, losing 3 electrons moves you here, okay? Aluminum ion is isoelectronic with neon. So to answer this question, we would write the electron configuration for that noble gas. So for aluminum, it would be 1s2, 2s2, 2p6, okay? Barium is going to be isoelectronic with, let's just show you where it is. So here's barium. And barium has a 2+ charge, so it's going to lose 2 electrons and be isoelectronic with xenon. I'm going to do a shorthand configuration to this because I'm not feeling like I want to write the entire thing out. So if we're doing the configuration for xenon, we're going to start from krypton, and then from there, we're going to go 5s2, 4p10, 5p6. So if you're getting the hang of it, now selenium has a 2- charge. So 2- charge means that we would be gaining 2 electrons. And so if we see selenium is right here, gaining 2 electrons would make it isoelectronic with krypton. So the shorthand configuration for that would be argon, and then 4s2, 3d10, 4p6. And the last one is iodine. Iodine is, erase those, right here. Gaining 1 electron would make you isoelectronic with xenon. So that would be, sorry, 1 second here. The pencil stopped working. All right, there we go. So we've got xenon, so we're going to start from krypton. And it's going to be 5s2, 4p10, 5p6. And you can see the iodine ion is going to have the exact same configuration as a barium ion, which has the exact same configuration as xenon. They're all isoelectronic. All right, so for the next problem, it says to predict empirical formulas of the ionic compounds formed from the following pairs of elements, name each compound. So I don't care so much about the naming right now, but I'm still going to show you guys how to do it. And then remember, empirical formulas for ionic compounds are the actual formula. So we have lithium and we've got nitrogen. Now the first thing you want to do is you need to write down what their charges would be. Remember, ionic compounds are a bond between ions. So the lithium ion is going to be a positive 1, and nitrogen is going to be 3-. And we know this based on what group they're in. All right, lithium's right here in group 1. Everything in group 1 is positive 1. And then group 15, we have nitrogen. Everything in that group has a -3 charge. Now remember, these are going to come together in a way so that their overall charge adds up to 0. So in order to do that, I would need 3 lithiums to cancel out that -3 charge from nitrogen. So when you do that, you get Li3N. Another little shortcut for this, if you want to use it, is when we write formulas for ionic compounds, we use what we call the Crisscross Rule. which means you take the 3 and you bring it down here. You bring the 1 and you bring it down there. Crisscrossing them cancels out the charges, and that's going to give you the formula Li3N, just like I showed you. Now what do we call this? So you name the first element that you see, and you don't do anything to its name. So lithium is the metal, we call it lithium. But the second element, the anion there, we change its ending to an IDE ending. So nitrogen becomes nitride. So that's how we do A. For B, we've got gallium, and we've got oxygen. So again, just like we were doing before, we need to go through and find out their charges. Gallium is in the same group as boron and aluminum. It's a positive 3 charge. Oxygen's a -2. Crisscross them is going to give you your answer of Ga2O3. And this is going to be gallium oxide. For part C, we got rubidium and chlorine. Rubidium's in group 2. Sorry, not group 2, group 1, so it'll be a positive 1 charge. Chlorine's a negative 1 charge. You can see right now those charges are going to cancel each other out. So that's going to give you the formula RbCl. And the name of this, rubidium chloride. And then our last one, for part D, we got barium and we got sulfur. Barium's in group 2. Everything in there is a positive 2. Sulfur is an oxygen group, so that's going to be a -2 charge. Those charges cancel each other out as well, so you're going to have the formula BAS. You name the first element you see, barium, and then the second element gets that IDE ending, so we get sulfide. All right, question 45 is just like number 41 that we did earlier, where you're writing the configuration of these ions. And you need to remember a stable ion is going to be isoelectronic with a noble gas. So these are the 3 ions that we're doing. These are cations because they're all positively charged. And so we've got magnesium first, we've got potassium second after that, and then we're going to have aluminum next. Now with magnesium, 2+ means you're losing 2 electrons, which means you're going to be isoelectronic with neon. So we're going to write the configuration for that. Let's use blue. And so the configuration for neon, I'll do the longhand, is 1s2, 2s2, 2p6. Potassium, you lose 1 electron, which means you'd be isoelectronic with argon. So the configuration for argon would be 1s2, 2s2, 2p6, 3s2, 3p6. And then lastly, the aluminum ion has a positive 3 charge, which means we're losing 3 electrons. We'd be isoelectronic with neon just like earlier. So 1s2, 2s2, 2p6. You can see this aluminum ion has the exact same number of electrons as that magnesium ion does. Now we're going to do the second part of this question where we're going to find out the anions configuration. So the 3 anions in this question were nitride, oxide, fluoride, and telluride. Now these are all anions because they're negatively charged. Okay, so let me erase the ones from earlier here. So the 4 ions we're looking at here, we've got nitride, we've got oxide, we've got fluoride, we've got telluride down here. Now for nitride, we are gaining 3 electrons, which means we had 7 electrons to start with. Gaining 3 means we're going to be over here where neon is. So the electron configuration for neon is 1s2, 2s2, 2p6. Oxide is gaining 2 electrons. That also will be isoelectronic with the neon noble gas. So 1s2, 2s2, 2p6. And predictably, fluoride has a -1 charge, gains 1 electron, also isoelectronic with neon. So 1s2, 2s2, 2p6. All three of these ions have the exact same number of electrons. Telluride is different. It's got a 2- charge, but gaining 2 electrons brings you over here to xenon. So if I'm writing the configuration for xenon, that's too big to go longhand, so we'll keep it short. So it's going to start with krypton, the noble gas before it, and then we're going to go 5s2, 4d10, 5p6. All right, so last question for this assignment was number 49, and it says to give the formula of a negative ion that had the same number of electrons as each of the following positive ions. Now there's more than one answer possible for each of these, so I'm just going to give you one for each, but just know that there are more than one answer. And again, when we say same number of electrons, this is where we want to use that term isoelectronic. All right, same number of electrons means you'll have the exact same configuration as something else. So let's start with the sodium. Sodium's right there. Now that sodium plus means that it's a positive 1 charge, which means you lose 1 electron, which would make you isoelectronic with neon. So we need to find a negative ion that would have the exact same number of electrons as neon. And again, there are a few choices, and the previous problem that we did before this kind of helps with it. I think some possibilities that I can lay out right now, the fluoride ion, which is a negative 1 charge, would be the exact same number of electrons as neon. The oxide ion would as well. And lastly, the nitride ion. We saw those three last problem where all three of them had the same configuration as neon. Now for part B, we've got calcium ion. 2 plus means you've lost 2 electrons, so now, let me erase it so we're looking a little cleaner here. So again, calcium ions going to have the same number of electrons as argon. So what negative ions would have the exact same number of electrons as argon there? Well, chloride, which is right next to it, so Cl-1, sulfide, and phosphide. Kind of the exact same pattern I just did on the previous part right before it. All three of those are going to be isoelectronic with argon as well. For part C, we got the aluminum ion. Now the aluminum ion has a positive 3 charge right here. Losing 3 electrons means it would have the same number of electrons as neon. So your answer for part A works here for part C. F minus, O2 minus, N3 minus are all possibilities that work here. And then lastly for D, we've got rubidium. Now rubidium's in group 1, so it has a positive 1 charge right here. Losing 1 electron makes you isoelectronic with krypton. So for these ions, I'm going to focus on these anions over here. So the bromide ion, minus 1 charge, is isoelectronic with krypton. The selenium 2- ion is isoelectronic. And lastly, the arsenide one is, with a 3- charge. So hopefully this helps. If you guys have any questions, come see me in class so I can help you guys out with some more questions. Peace.